Where does silver actually come from, and how is it truly made? From the antique tea sets passed down through families to the coins in our pockets and the complex circuits hidden inside our smartphones, silver is woven into the fabric of modern life. Yet this brilliant, reflective metal doesn't start its journey looking polished or precious. Its story begins deep beneath the Earth's surface, trapped inside unremarkable stone. So, how does a rough, dusty rock transform into one of the most recognizable and valuable metals in human history? Silver is a natural chemical element identified on the periodic table by the symbol Ag. While it exists throughout the Earth's crust, it almost never appears as a pure, standalone metal. Instead, silver is usually hidden within other minerals. One of the most frequent sources is galena, a lead sulfide ore that often contains significant traces of silver deep within its structure. Silver is also commonly found mixed with copper, gold, or zinc. In fact, a large portion of the silver used today isn't mined on its own at all. It is recovered as a secondary product during the extraction of these other industrial metals. To access these deposits, miners rely on either open-pit mining or underground methods, depending on how deep the ore lies. When silver-bearing rock is located near the surface, massive excavation equipment removes layers of soil and stone, known as overburden, to expose and collect huge quantities of ore. For deeper deposits, miners must dig intricate tunnels or sink vertical shafts to reach the metal-rich rock far below. Regardless of the method used, the freshly mined material is far from shiny. At this stage, it's nothing more than a dense, dull gray mass of rock that must undergo several complex processes before it can become usable silver. Once brought to the surface, the silver containing ore enters a mechanical transformation. The process begins with crushing, where enormous jaw or cone crushers break the large rocks into smaller fragments. These pieces are then fed into ball mills, where rotating steel balls grind the material into an ultrafine powder similar in texture to flour. This step isn't just about size, it's about efficiency. Smaller particles mean a greater surface area, which makes it much easier to separate the silver from the unwanted rock. After grinding, the material becomes a thick mixture of water and powdered, or known as slurry. It is within this slurry that silver starts to part ways with the surrounding waste. The next stage is called flotation, a method especially useful when silver occurs alongside metals like lead or copper. Specific chemicals are added to the slurry, and air is pumped through the mixture. The reaction is surprisingly clever. The chemicals cause the silver-bearing minerals to repel water and attach themselves to air bubbles instead. As the bubbles rise, they carry these valuable particles upward, forming a thick, foamy layer on the surface. This foam is carefully removed and dried, leaving behind what is known as silver concentrate. Even now, it isn't pure silver. The concentrate still contains a combination of other metals and impurities. That's when true purification begins. The next stage is smelting, a process where intense heat transforms solid rock into molten metal. The silver concentrate is fed into a furnace and heated too, temperatures that often exceed 1,800 degrees Fahrenheit. At these extreme levels, the materials melt and naturally separate by weight. Silver, being denser than most contaminants, settles at the bottom of the furnace, while lighter waste materials form a layer called slag, which floats to the top and is removed. When lead is present, an ancient technique known as cupellation is used. Taking advantage of lead's ability to absorb silver before being oxidized away, leaving behind solid, metallic silver. While the metal now looks recognizable bright, soft, and reflective, it still isn't pure enough for precision uses. To reach the ultra-high purity needed for electronics, fine jewelry, and investment-grade bullion, silver undergoes electrolytic refining. This process uses electricity to cleanse the metal at an atomic scale. Impure silver serves as the anode, while a thin plate of pure silver acts as the cathode, both submerged in a silver nitrate solution. As an electric current is applied, silver atoms dissolve from the anode and reform on the cathode as nearly flawless silver. Other metals, including gold and platinum, sink to the bottom as a residue known as anode slime, which is collected and processed separately. Once refining is complete, the result is silver that is 99.9% pure, commonly referred to as 3 nines fine. This is the standard used for premium silverware, collectible coins, and advanced electronic components. The purified metal is typically molded into large bars or ingots for transport, storage, or sale. These ingots can later be melted down and shaped into countless products. From ultra-thin wires for electronics to wide sheets used in solar panels or delicate forms crafted into jewelry. While silver may seem like a relic of the past, its importance in our high-tech world is actually growing. Beyond decorative items, silver plays a vital role in modern technology as an essential component in smartphones, electrical connectors, medical instruments, and even water purification systems. Thanks to its natural antimicrobial properties, silver is also used in wound care and surgical tools where hygiene is critical. Beyond its practical uses, silver continues to hold financial significance, remaining a trusted choice for investors worldwide. So, the next time you notice a silver ring or handle a silver coin, remember that its shine carries a deeper story. Behind that glow lies a long journey that begins underground and passes through crushing, heating, refining, and reshaping. It is a story driven by science, guided by tradition, and perfected through skilled craftsmanship. Silver doesn't simply exist in its finished form. It is created through human knowledge and effort, refined over centuries. In the end, silver serves as a quiet reminder that even the most ordinary objects can have extraordinary origins.